Hello, everyone. Today is a big day for us. Welcome to the Info 7275 project presentation. Team 1, are you ready to present? We cannot hear you yet, Team 1.
Hi, Professor. We are ready to present. Can
Yeah.
you give the sharing rights to Aditya?
I think you can you figure out some other way because that's pretty tedious. So do you have you have a one member presenting the
Yes.
slide, and then
Yes,
everyone
Professor.
else will require sharing that desktop, right?
Yes.
Can you do
Aditya
it,
will be presenting on behalf of all of us.
or can you do that on your own, or do I need to do that for each and every of your members?
Uh, y-
Yeah, I think
yeah.
your slides are on.
So should we start, Professor?
Yeah, you are on, team one. We are waiting on you.
So okay. So for our final ADBMS project, we have decided to mimic a database of an e-commerce website that we are calling Amazon Lite. So these are my team members: Aditya Dharangaonkar, Anurag Racha, Gayatri Rettiar, and myself, Milan Desai. So this is the agenda of our presentations that my teammates and I will be presenting today and covering during the presentation. So the main objective of our project is to store the data in Cosmos DB and use its advantage for higher throughput and low latency, which was to inject into the Cosmos using ETL in Python and to process the data using Python. So we have applied sentiment analysis on the reviews of the customers to highlight the high versus low performing products. We have we decided to use Cosmos DB for its geo-replication feature and SQL and API support, which makes it easier to query. We also used it for its flexible schemas and hierarchical data. So my teammate Gayatri will continue from here.
Um, s- So this is our entity relationship diagram. We essentially have four main data sets, namely the customers data, sales, reviews, and product catalog data. The customers data has the customer's demographic information. Sales data has the purchase history of every customer. Reviews data has the product reviews, given by each of the customer for the different products. And product catalog has the product data. So we also have product recommendations data that has been generated for each of the customer using the customer's purchase behavior, and we have sentiment data, which is essentially for giving sentiment scores which have been derived from the reviews data given by the customers for a given product. So next is the architecture diagram. So prior to running the ETL on our data and doing the subsequent analysis, we did a preliminary data profiling using Trifacta to check for any data quality issues that were to be considered before cleaning the data. So the issues that we identified in Trifacta in terms of the consistency of the data types, checking for null values, etc. Those were handled using Python, specifically the pandas library in Python, which we also use to run our ML models. We essentially use the collaborative filtering technique to generate our product recommendations and use the Vader algorithm for generating the product sentiment. Um, After the data which has been analyzed in Python was then pushed to the Cosmos DB using Python's Azure Cosmos DB SQL API. We have also developed a front end application in React.js where we are showing our Power BI visualizations as well as the product recommendations that we generated for each of the customers. So this has been essentially implemented using a Flask backend, which makes the required API call to generate the product recommendations. Next up is Aditya.
For data cleaning and integration, as the data came from multiple sources, there was a little data consistency. So the inconsistencies was mainly in data types, precisions, handling of null values or missing values, some of which were blank, some of them were hexadecimal or meaningless data. These were highlighted in our data profiling phase. We figured out the fields which were necessary for our business analysis in our data profiling phase, and we omitted out the other meaningless fields and did our data cleaning and consistency checks on the meaningful fields. Using pandas, we achieved our data architecture, which was showed in our ERD. For sentiment analysis, we used Vader. Vader is a valence-aware dictionary for sentiment reasoning, is a model used for text analysis that is sensitive to both polarity, that is like positive, negative, and intensity of emotion. It is available in NLTK package and can be applied directly to the unlabeled text data. So it is a unsupervised method of machine learning. These sentiments are then aggregated per product and added to the product catalog. For recommender systems, we are using NCF, which is user to item affinity matrix to recommend new items. Each user is recommended 5 products. We are planning to update the sentiment and recommendations every month, so it will be monthly updates. Next up, Anurag will be showing the demo and the analysis.
Hello everyone. I'll just head on to the demo process first. So this is our React.js application, and as this is our homepage, here we are showing the predictions that we have for the items for each of our user IDs. So as this text field, we enter our user IDs over here, which then goes on to our Flask API backend for the API call. And according to the ID that we send over here, it queries for the data set that we have on Cosmos DB, and then it gives out the item and its prediction value that we have over here. So say if I were to get predictions for our user ID number 1, so we get the item IDs that we have and the prediction percentage that we identify. The way this percentage works is the higher the number is the most uh, recommended product for that user. So 3228 is the product that would definitely be something that the this user would buy. So that is how this goes. And second thing we did is we also have a Power BI dashboard, which was mainly centric around to get sales analytics for our stakeholders and so forth. But instead of just making that, we also integrated that into our React.js, which is from here. We navigate to our Power BI dashboard. This would be only for our stakeholders, and the first page of our dashboard would be the demographics to like for each customer ID. As we have a slicer, we would get data for those customers. Moving forward, we have invoice breakdown. So for invoices that we have, we could also, so the way this works is it has two slices that work on this page. So for that customer ID, there could be different invoices, and for any specific invoice, we would get what products have been bought by that user and all the, oh sorry, the sales that have been generated by that user, and the most important values that we can find from invoices, that is identifying which customer it was and the total amount that he has been getting from that invoice. All of that information is right here. Now for the team to identify the analysis from the data that we have sales breakdown. So this is a very typical sales format graph that we have, which is divided into quarter-wise sales and month-wise sales. So the analysis that we have here is to identify number of products that were sold in quarter one and the amount that was generated from selling that quarter, selling that amount in that quarter. And understanding the trend from each quarter, we can also then navigate to month-wise sales given right there to identify the same analysis throughout every month for the years. Next, we go to product breakdown to identify which products have been selling the best. And this could then further move on to marketing strategies to identify which products do you want to sell most, or even know maybe which product have been not selling and what are the reasons they're not selling. Lastly, we have product performance, where based on the reviews that we had as data for, through our customers, we used analysis to identify which reviews have been the most positive, to identify if this product has been receiving the most amount of positive replies. So then that also can be the part of the marketing strategies to identify if product needs some workaround and decisions so forth. So this is the way we've tried to put the dashboard as product as a service to identify everything through buttons and so forth. So this was a live demo and our analysis for the projects. Um, yeah, that's it. Thank you so much, guys. Hope we all liked your project and we are open to questions, if any.
Okay, hi team one. So this is team A. Nice to meet you. So I should have about like 2 questions so far. So like, can you go over the prediction value, because like I don't understand how can you generate that number?
Sure, 1 second. So basically the thing is, can you hear me?
Yeah, I can hear you.
Yeah. So basically the thing is, every user has been assigned, has a similarity index. So how close the product is to that user in the vector space. So this is nothing but the distance between the matrix, like those two vectors, this item and this user and this item. So that is nothing but the distance between the user and the item, and the inverse of it. So the more the value, the more affinity the user has to the item.
Okay, so my second question is like, assuming like you have like a new set of data, let's
Mhm.
say new month or like new year whatsoever. So like, how long is it from you to import the data, process everything from start to finish? Like, how long does it take?
Okay, so I will show you in my PPT. The main thing, the main time which we got, it was when we were trying to import the data into the Cosmos DB. So for our data, for our 1 year data, it took around 2 to 2.5 hours to get the data into Cosmos DB. So that was the only time which we thought was a bit high. Other than that, and of course there was some time in training the Vader Vader model as well, and the recommender system model as well. So I guess the whole system would take around 5 to 6 hours of processing.
Okay, yeah, thank you. I have no other question.
Yeah, and that's why we have a plan to do a monthly update for our data. So because it takes so much of time. Thank you so much. Any other questions you have for me, Professor? You too.
Excellent work and excellent presentation from Team One. I really like your data analysis. Thank you for the great work and thank you for the questions from Team 8.
Thank you, Professor. I'll stop sharing my screen now.
Sure, yeah, let's welcome Team 2.
Can we start?
Yeah, you are on Team 2.
All right. Hey guys, this is Team 2 and our topic is online education data management system based on Cassandra. Next slide. We have 5 parts for introduction, including project plan design, data implement, visualization, and question and answer. The first part is project plan. All are divided into project background and introduction. For the background, we are trying to study China's online education environment and compile provided courses on different platforms, such as EDU, TLL, and others. We also try to study the statistics of people using online education and analyze growth rate in different platforms. We hope to help all those who want to take online lessons by collecting and analyzing data. As you can see, we use web scraping with Python to get data source. We analyze that URL has 3 variables: section, grade, and subject. There are 72 combinations. There is 72 different URLs, and each URL has several corresponding courses. This web scraping with Python is to crawl the URL 72 times and then assign the corresponding section, grade, and subject files to the corresponding courses. The course information includes the files such as name, time, teacher, number of applications, price, and others, then aggregates them into a table nested dictionary structure for use. Among them, the teacher's information sheet comes up with a list, and each teacher has a corresponding course ID, which is used to associate with the course information table. Finally, 2 Excel sets are output. One is a list of courses, and the other is a list of teachers. Next page, with Columnar as our data model, and Cassandra as a target platform. We use TableView as a visualization tool and Python as transformation tool. As for loading tool, we use the Cassandra driver with Python and also some Cassandra queries. Back a little bit. Next page. This one. For part 2, we'll introduce the ER diagram and the architecture diagram. Next slide. For ER diagram, we have 10 tables. As you can see, there are grade tables, sales tables, subject table, course table, which is most important, teacher table, teacher review table, sciences teacher table, teacher review table, online platform table, and a course review table. And they connect each other by primary keys and foreign keys. Next slide. And for project architecture, we will use web scraping for downloading source from online. And then we will clean our raw data by Python and load our data into Cassandra. And to output our data, we will use the TableView as a virtualization and also discovery as well. That's my part.
Hi, I will introduce the implement part about processing data and loading data into Cassandra database. The first is about data processing. Oh. Okay. Okay, sure. About this slide. After we scraped the data from website, I loaded raw data into Python by using NumPy. By using NumPy and Pandas library in Jupyter Notebook, I checked the data quality for accuracy, completeness, and consistency. After that, I did data manipulation, such as remove duplicate data, missing values, filter key columns, and format the data type, and so on. Finally, I loaded the data into Cassandra database by using Cassandra driver in Python. There are 4 steps. The first is connect to Cassandra database. There are we can see the code screenshot in Python. The second step is create a table. We create a teacher table, course table, category table, and so on. After I create the tables, I insert the data into Cassandra database. This is a part in Python. After we create all tables and insert all data, we check the data in SQL console we check the tables. It will show we have platform table, grid table, and so on. And we check the detailed data as this. Okay, next part is about visualization.
Oh yeah, finally we use Tableau as a visualization tool to work with our Cassandra database. Next slide, please. With data visualization, we can clearly learn about China's online education situation. Use Tableau, we have created 3 stories and 10 diagrams in total. The stories include course count statistic and course sales statistic and course rank. Next slide, please. Oh yeah. The first story is tell about the course count. As you can see, the first diagram, which shows course count by grade ranging from kindergarten to grade 12. And the second diagram is the line chart. From this line chart, we could tell the course count tendency from February 2020 to March 2021. And the third and the fourth diagram shows the course count percentage by the subject. And it can easily tell the fittest, it contains the most part. Next slide, please. And the story 2, the goal of the story 2 is learn about the course sale. From the diagram, the first diagram, we could scout the average price by the grid. And also from the second diagram.
Sorry, there's just 1 minute left.
Oh yeah, sorry. I will quick. From the second diagram, we can see the average price, course, quantity, sold quantity, and percentage of sold from for the each subject. And also we could see the course revenue by the grade, which can easily tell. And please next slide. For the story 3, we want to get to know the most popular course with this value. So we created different rank to present. The first rank is the top 3 course with the most revenue within each grade. And the second rank is the top 3 course with the most revenue within each subject. And the last rank is top 10 course with the longest sale time. Next slide, please. And for the data refresh, we will running our web scraping script monthly. So we will continue to get our new data, then put the data into our ETL pipeline, which will clean the data and then persist data into our Cassandra database. Then by using Tableau, we can get the latest data visualization. And next slide. Yeah, that's it. Thanks. If you have any question, please ask.
Hi, thank you for the presentation. It was really good. I just have one question. Is there a specific reason why that you went with Cassandra for this particular use case?
Yeah. Well, Cassandra database is NoSQL database. It's fast and convenient for data loading and data processing. So I think this is the reason we mainly use that.
Hi, we have another question. Could
Yeah,
you
yeah.
tell us if the connection to Tableau was directly through Cassandra, or did you have to export those files to get those visualization connections to Tableau?
Yeah, at first we try using directly connect with Tableau but we found out it has not first class driver for connecting. So we found out there's a ODBC connector which using Symbus company. So we use that driver to setting up the connect with the Cassandra.
All right, thank you so much.
Yeah, you're welcome.
Any other question or comment for team 2? Okay, great work and presentation from team 2. Excellent questions and answers. Thank you all for the great contribution to the project presentation. Let's welcome team 3.
Hello, everyone. We are a RangoDB team working on YouTube trending analysis, and our group member Qimeng Jing, Yuwei Zhang, Hui Tang, and Sheng Jiang. Next page, please. There are 4 parts in our presentation today: design architecture, data overview and implementation, data visualization, and data deliverable. First, design architecture. Collect data from the internet, convert it into JSON format, and save in RangoDB. Do data visualization with Power BI and Tableau, present it to the users, and the users can do some query operations on RangoDB. Next part is data overview. The data set includes several months of data on daily trending YouTube videos. Data is including for the United States, Great British, France, Germany, Canada, Japan, and in regions with up to 200 least trending videos per day. Next page, please. The data set is a daily record of the top trending YouTube videos and was collected from the cargo data sets, which used the YouTube API. Now let's welcome my partner Yu Wei to show you data implementation part.
Next, please. We use Python Jupyter Notebook to deal with the raw data sets, the CSV files, and import the processed data into the corresponding collections of ArongoDB as JSON documents. Next, please. By using Jupyter Notebook, we partition the videos with 8 country fields, filter out some data to focus on the most trending videos, replace the null values, and convert string to the appropriate datetime data type. In the process of exporting our data into JSON format, we found that the category file is nested, which requires us to flatten the file and pick out the elements we need to transform. We can see the picture on the left side. It is hard to find the information we need because it's nested, which takes us looking for the useful information line by line, but after transforming the format, it's neat and obvious. Next, please. We create 3 collections, the video information, category, and region on ArongoDB to place the corresponding documents. Next, please. This page is our ER diagram. We have 3 tables: the video, category, and region. The video connects category by category ID and connects region by the region ID. Next. We import the documents to ArongoDB through the command lines and upload in web interface. So here are the pictures of what it looks like in ArongoDB. Next. And this page is an example of one basic query. We try to find the category and the video information of Marshmallow's channel, filter the video and join the category and the region. And on the right side, we can see a Arango search to find the video information containing the specific phrase of video text. Like here, it comes up with all videos with Billie Eilish in the video title. Next, please. And this page shows how to create the view and the function to ArongoDB and sort the data through the Arango shell. Yeah, that's it.
Okay, so for data visualization, we use the Tableau connector in the ArongoDB, and to connect the Tableau through the web data connector, then we fill the data table information in those fields. So in the Tableau, we create calculated fields days after. Since different videos have different publish time and training dates, so it's better to create a days after field. So it's better for comparison. Then we also build trending movements tracker. So this tracker have two views. One is individual video. The other one is about video channels. Then we have the days after as the page. So the movement will evolve through in this days after. We also can filter the channel title, like a channel, and or videos as we want, if we want to search a specific channel or specific videos. So by clicking specific videos, we can see the movements from day 1 to day, like for this example, from day 1 to day 10, the video BTS, fake love, we can see the comment count, dislikes, likes, views. We also create a lot of visualizations, such as total views, top hit videos, and also category in each country, which we will discuss more in data analysis.
So based on our database and our data revelation, we have several data deliverables. So for the first one, in the background, it has a simple data revelation. It's including some information based on the region. And so for data user, it's pretty easy to find basic information and some statistic information by region. So sometimes people from different region may have some different video preference, sorry. So by locating and understanding data by region, sometimes will help user understand which kind of video can be welcome in which specific region. It will definitely help with some global marketing strategy. So for the second, next. On the left, it has top 10 total wealth videos. So 9 of 10 is from music category, and 1 of 10 is from entertainment category. And also for music, it has nearly 53% of total wealth. And also if channel number is number 3 of all the category. And also for entertainment, it has 20% of total wealth, and the channel number is number 1 out of all the category. So for the data user, it's pretty easy to find like top 10 wealth video, but not only top 10, you can define it. You can do top 20, top 50, top 100. It can like billboard. And also you can know the number of likes, dislikes, channels, tags by category. So the user can explore which kind of category is the most popular one, which with the information of category performance, it will help user know more details about which category have huge markets with big potential and wild prospects. And next. And also for users, it's easy to find the well likes dislike number by time. So besides category and region, time is also an important feature need to be considered when users try to find the pattern of the YouTube video trending. So by understanding on which day, what time there will be more visitors or watchers, it will help users make decisions, like when they want to post videos and advertisement. So on the right, it has a simple data verification as well from Sunday to Saturday. Normally on Friday, there will be much more watchers. And also on each day, on different time, it has some slightly different, like from 3 p.m. to 5 p.m., it has a little bit over 19% wealth. And a little bit weird, but on 4 a.m. to 5 a.m., it has nearly 19% wealth. And also like 12 p.m. to 2 p.m., it has almost 16% wealth. So my teammates will do the demo.
Okay, so So Tableau is very slow, so we will talk Arango search first. So we pre-define the views first, then we can do queries. Basically, you can enter whatever words you want to search, like whatever words you want in the text, you can search the videos. So if I enter SQL, it will jump out the SQL, like video associated with the SQL. Then if I want to see, if I want to do the basketball, then it will jump to, because the tag contains the basketball, so you will find the videos associated with it. So for the tableaus, basically you can select the views you want. It's really slow because it's a lot of data. Basically, you can click. You can click it, and so this one is from day 1 to day 4. You can see the movements, and you can hover it and see the title, command count, dislikes, likes, and views. Yeah, the same thing with the video channel. And let's go to. Yeah, you guys have any questions?
What is your most challenging part in your project?
I think the most challenging part is like, if we have information about the video, where the video made from, then we can do the to from, then we have to from relationships, so we can do the graphs, right? But now we only have the, like, where the video is played, so we cannot do the graph, so it's only the document. So that's, I think that's the part we really wish we have, but it doesn't. And that's kind of like challenging part, only do the documents, because we're really trying to want to do the graph. Yeah.
Yeah, thank you.
Any other question for the ArangoDB team? Excellent work and presentation from the ArangoDB team.
Thank
and
you.
I really like the question and the answer. It was very insightful. And also your Tableau was relatively slow.
Yeah, it's
did you use the cloud version of Tableau?
Yeah, I was trying to use the cloud version. It's ton of data, so.
Oh, okay. So you used the cloud version of Tableau, right? And there's so much data.
No, I publish it in the Tableau public, so.
Oh, I see.
Yeah.
But you are running, what you are running now, is that your local Tableau or is that in the cloud?
In the cloud.
In the cloud, okay. Okay,
yeah.
Thank you.
Mm-hmm.
Excellent work and excellent presentation. Thank you very much, the ArangoDB team. Let's welcome Team 4.
Hi, Professor. Can you hear me? Hello.
Welcome, Team 4. You are on.
Can you hear me, Professor?
Yeah, sure. You are on.
Yeah. So we are Team 4, and we will be presenting about IMDb movies. And our database is MongoDB. We selected MongoDB because firstly, it's extremely easy to install and set up on any desktop. Secondly, it doesn't have a definite schema. And this is the main advantage of using MongoDB, since it's really flexible and each document can be different from the other. Thirdly, performance is also generally very high using MongoDB. And fourthly, it's also extremely cost effective compared to other SQL databases like SQL Server and Oracle. And the main objectives of this project are to analyze the movies by genre, which make maximum profit by year. Then to compare critic reviews versus user reviews for various movies. Then to determine the popularity of various movies across genres by comparing the average male to female votes. Also to analyze the increase and decrease in the number of movies released for each genre over the years. And the last objective would be to find out which movies are getting the majority ratings, which are greater than or equal to a certain number compared to the total votes for the movie. Okay, so this was data source. We had 4 main data sources. One was the movies data set, which had all attributes about movies, which included the description, the number of votes per movie, the rating, the budget, the gross income worldwide and in USA. The names data set, which included all the information about the actors and actresses and everyone who was a part of the movie, including their birth details, the height, and all their personal information. Third would be the ratings, which would include all types of ratings for all like genders, like the male ratings for a particular, then the female ratings based on the number of ratings for each rating, like for rating 8, 7, 6, 5, etc. on IMDb. And lastly, title principles, which would include all the cast members' information, such as the title ID, the name ID, and the roles and the character played in the movie. This is the ERD diagram. And over here, the cast names will be connected to the title principles of the cast role via the name ID, which would be the primary key. The cast role would be connected to the movies data set via the title ID, and the movies data set would be connected to the ratings data set via title ID. And the next part will be explained by my teammate Rahil.
All right, so now this is our basic data architecture diagram. So like this is a idea about like how the data flows in our entire system. So like we have 3 parts: the sources, the storage and the transformation, and the analysis part. So basically, as you see on the left, it's the data source. We had our 4 CSV files from the IMDb site from Kaggle, and like initially we had also like converted them from CSV to JSON as we might need them going forward. Then, as we know that like all the data which we get from online tools is not always clean and consistent. So we used Talent for data profiling purpose and the cleaning part, and then we also used Python there. Then the cleaned data was then imported to the MongoDB via MongoDB Compass, which I think everyone is aware of, and MongoDB Compass like directly allows you to import the CSV files. So like it was a pretty smooth process for the import part, and like it creates the documents based on your data. And then we also did some querying in the MongoDB in the Compass itself. Like we have the aggregation tab where you can use the various parts like group by, lookup, and stuff like that. And for BI and reporting, like initially we had planned to use Tableau, but then like we switched over to Mongo Charts as we learned that it is like very well integrated with MongoDB, and like it won't require any extra connectors. Next slide, please. All right, so like we did some data profiling by using Talent. So like why do we need Talent here? So first of all, like all the data which we get, like it's not always clean and consistent. Like we have some formatting issues, like some like if you have multiple date columns, then the format might not be the same. Then like this also, so like we perform the column analysis on all the 4 CSV files.
which helped us to know that like how many null values we have, and then like what are duplicates we have, how many alphanumeric columns and stuff like that. So based on that, we can decide our plan that how are you going to clean this data before you can load it in our source. So going towards the next slide, please. So data cleaning in Python. So like we use the pandas library to manipulate all our data sources. So as you see here, the first data frame, and like it had a field called budget. And so in our original data set, we had the column with alphanumeric. So like it had the currency signs as well as the values. So like the currency signs were making it tough to aggregate. So we had to use regex to remove those paths. Then we also removed all the columns which were not required for our analysis, and like that saved us a lot of data storage space. And then we had a CSV file called ratings, and it had few null values. So we imputed them with the mean values of that column. So just to give us a precise analysis going forward. And now going forward, next number, Monali can explain the rest part.
Okay, hello everyone. Hello, Professor. So once we have clean data after checking data quality and data profiling, we have imported data into MongoDB database using MongoDB Compass tools. So now we have data in document based in JSON format. Can you go to next slide, please? Yeah, thanks. Then we have implemented our ERD in MongoDB by joining all 4 collections. So we have used lookup function for that, and we have joined all the collection using lookup function. So we have total 3 lookup in our data sets, movies to rating, movies to title, and names to titles. So here is the one example of the lookup. So here we have joined movies with rating collection using lookup function. And it is same as primary key and foreign key concept, like a SQL. So we have joined both collection on IMDb title ID. And here, like in our project, we have used referencing technique for joining. Can you go to next slide? After that, we have performed database queries on MongoDB dataset to calculate some key metrics and to analyze the data. So here is the one example of the query that we have performed. So we have determined the top movies by genre and year. And for that, first we use a lookup function to join movies and rating collection. Then we have used limit function to maximize the number of record to be returned. So like we wanted to have movies by genre and year. So for that, we have used group function, and then we have used maximum aggregation function on column US voters to determine the top movies. Next, please. Okay, so next is this one is another example of database queries to determine top director based on overall ratings. So to determine this, we have used a group function to group all the directors, and then we have used average function to calculate the average votings, and then we have used sort function for ascending and descending purpose. So here is average rating is -1. That means return data is in descending format, else it is in ascending format. So now Swetang will continue from here.
Hello everyone. For the visualization, we created visualizations in MongoDB charts. So this is, there are few of the visualizations. The first one is top 10 movies by number of reviews given by the user. So we can see Joker has highest number of reviews received by the users. Then is Avengers Endgame, and so on. Next slide, please. This is another visualization that is describing the movies based on the total votes. So this is a donut chart where we can see that there are movies with their votes. So the purple one has the highest number of votes. There are movies like Inception, Fight Club, who has received the highest number of votes. Next slide. The next visualization is the top 10 genres based on the average votes. So this visualization describes the famous genres based on their votes. So drama has the highest number of average votes been received. Then is comedy, then is comedy, drama, etc. So can you, Aditya, can you switch to the dashboard so we can describe or explain few more visualizations? So yeah, you can see the second one, top 10 movies based on the number of critic reviews. So on the y-axis we have the titles, and on the x-axis we have the reviews for that reviews received for that movie names. Yeah, so the geographical visualization based on the countries that give votes, then number of votes received for the movie based on the gender, that is male and females. Can you go down? So these are the lowest rated movies by votes. There are movies which have received lowest number of votes, that are the movies like The Promise, etc., Twilight. So yeah, that's it from Team 4. We are open to questions.
I'm sorry, I'm not sure if I missed it, but did you put your data structure in your presentation? Did you put it in the PowerPoint? Like the tables for your database?
So are you asking when we imported the data?
Yeah, like before you import your data, you need to.
Okay, yeah. So it's like we had to create basically 4 collections, like as you see on the left side of our screen, right? So we created those collections and then we imported the documents via the Compass import utilities. So like we had to just give a structure and then it was just automatically imported on its own.
Okay, so like under names, it will including the names of the movies, or
like the field names?
Like in the left, it has movies, names, ratings. So the names is for the movies, and like it just in different table, right? Like different collections.
Okay. So so there you are seeing names twice because like the names to titles part is the lookup view, while the original collection is just the names, right? So yeah, right? Got it?
Oh yeah. Sure.
Okay.
Thank you.
Thank you. Yeah.
Any other question or comment for Team 4? Thank you for the great work and presentation from Team 4. I really like your data analysis, and thank you for the question.
Thank you, Professor.
Sure. Let's welcome Team 5.
Can everyone see my screen?
Yeah, Team 5 is on.
Okay. Hi, good afternoon, everyone. We're Team 5, and I'm Yufei, and my teammates are Mei Chen and Wasani Oppo. Today, we're going to present the Amazon Product Data Management System project using MongoDB Altus as the target platform. The agenda for today's presentation includes the objectives, design overview, data integration, applications, and future work. There are 3 key objectives for this project. We aim to design a data management system for easily accessible product information, and we aim to improve searchability of products, including product descriptions, product ratings, customer reviews, offers, and inventory tag. Also, we aim to develop some interactive Mongo charts to present the valuable key insights into the database, and also to promote the effective business decision makings. There's no doubt that an efficient product data management system will definitely help the company to organize and regulate the data, because it will carry over the data from multiple sources, and it will enhance the customer experience because they can learn about the products from one place. We use the Amazon Movie Product API data as our key data source, and we use the those following 5 parameters to call the API and to get the comprehensive product data information. From a bestseller data API, we could get the top 50 bestseller movie products, and for each individual movie product, we got its name information, coupon information, customer reviews, stock level information, as well as offers and sellers information. The data architecture here basically shows the overall workflow of this project. Basically, we use a Python to call the Amazon Movie Product Data APIs, and we save those API JSON files into our local desk. And then we utilize the SIS as our data integration tool to extract the data from multiple API sources, ensure the data quality, and also transform the data into the target JSON format that match our ERD design. And then we loaded those JSON files directly from the SSIS into our target MongoDB database. Applications for this MongoDB database include the Mongo charts, as well as some special user cases that user can access the data currently stored into our MongoDB database. Moving to the ERD of this project, we choose to use the document database because we use MongoDB as our target platform, and we both utilize the embedding and referencing relationships for the data modeling. As you can see here, for example, for the product document, we embedded the customer reviews information, which include the most critical reviews, most positive reviews into the product document. And because, for one product, it may have multiple offers. Therefore, we use a referencing relationship here, and we put the product ID inside the offers document as a foreign key. And next, Opal is going to talk about more details about the data integration part.
Okay, so the next section here, we'll be talking about data integration on the fun ETL process of the project. As a reminder, we're working with 250 JSON files here, and those files were from 250 different APIs calls. So how would we go about consolidating the data from these different sources into a single data set? Our team decided to use Microsoft Integration Service, or SSIS. This is because the tools offer reusable ETL pipeline with simple but powerful data transformation. This allows us to prevent duplication of data, as well as giving us the ability to capture an audit log by using a staging table. If you look at a little map on the top right corner, that's the overview of the entire workflow of this project. But no worries, we're going over only a tiny section of this as an example. So at the bottom left, we started with loading the raw data from JSON file into one big staging table. Then the data in the staging table was cleaned, converted to a desired data type, and then loaded into a temp table in SSMS. In this process, primary keys were generated, and these keys were also added back to the staging table. So how did we prevent duplication of information when we assign a primary key to a new data? Here you can see from the call out on the right that we use a lookup tools in SSIS to check if the data points already exist in the database. If the data is truly new, it gets assigned a primary key while being added to the temp table. Next slide. Thank you. Now we repeated this process for every table until we arrive at the final step. The additional tool we're using here allows us to design a JSON document, then embedded some data to it. And finally, loaded the JSON document directly from SSIS to MongoDB Atlas, which is the cloud service of MongoDB. Next slide. Now let's take a quick look at the data that is now in Atlas. As you can see, we have 4 different collections of data in total: bestseller, inventory, products, and offers. And the picture on the right-hand side, that's an example of the document with layer of embedded data. Okay, now that all the data is in the database, my teammate Machen will show you how we made use of the data.
Thanks. Here we have some visualizations from MongoDB chart. First, we have the example for bestseller number 10. The histogram on the left is the price from all offers, and the table on the right shows the offer information such as seller name, offer price, and seller rating. Next, please. The donut chart shows the number of rating 1 to 5 stars of bestseller number 1, and the table at the right shows the percentage of the rating for all products. Next, please. Now, we have the histogram to show the comparison of the average offer price and recommended retail price for top 10 products. Next, please. From this table, we can get the product information for all top 50 bestseller from product review and inventory data. Next, please. Let's talk about the user cases. We have 7 user cases for product information, offers, and inventory management. Next, please. First, we have the overview product information. Users can get product information such as product ID, product name, rating, reviews, average offer price of each product. From the results snapshot, we can see all the information and even the most positive reviews and most negative reviews here. Next, please. Second, we have the rating scores of individual product. The result shows both number of ratings and overall percentage for all levels of ratings. For example, here, product ID 1 has rating score 4 with 883 reviews in total, and following with more details. Next, please. Product's top 3 offers overview shows the product information and the top 3 offer with seller information. Here we have product ID 1 as example, sorting offer price by ascending order. Next, please. Products offer and conditions shows the product information such as product ID and title with all the offer price and conditions, also sorting offer price by ascending orders. Next, please. Next, we have product offer price, summarizing the average offer price of the 50 bestsellers. Next. For the inventory management, we have all the products inventory information such as inventory ID, current inventory amount, and status. Users can easily check the inventory for the product. Next slide. Finally, we have the low inventory check, which shows all the products with less than a specific number in the inventory. In the example, we check all products which has less than 10 units. Next, please. For the future work, we can create triggers such as email or text notification to automate restocking based on predefined business rules. We need replica database to capture the audit trail to be able to create the trigger. We don't have the replica in the current account, so we cannot create here. Second, we can promote cross-selling and upselling by capturing also bought details for each product through Amazon recommendation system. Moreover, we can create archive table for all information and include timestamp for data integration. Okay, this concludes our presentation. Thank you. Any question?
So just one question, how do you go about cleaning this all the source files, because you said that you had to use a lot of source files. So how did you clean all the data?
Yeah, that's a really good question. So that's actually the reason we picked to do the ETL in SSIS, because it's a pretty powerful and easy tool to use. You build one ETL pipeline, and then we had the initial workflow for the first file pretty much sorry, I mean the first product, and then we have another control flow that we would use to add another product. And like I mentioned in my slide, you know, I use the, we use the lookup transformation tool just to make sure we did not capture any duplicate product. So yeah, after we ran the first product into the database, then the rest, like the, you know, the 49 products after that, we just use the update control flow to run that. So that's how we were able to, you know, process all the massive file. Did that
Okay.
answer your question?
Yeah. Thank you. Yeah.
Yeah. Any other questions?
Excellent work and the presentation end to end from team 5. And I have a question for team 5. How did you integrate SSIS with MongoDB?
Yeah. So we were, well, first of all, we would convert it, you know, we converted JSON document into relational database table. Sorry, just lots of word. And then we were able to put, you know, all the data back into JSON document using this additional tools that actually didn't come with the SSIS package originally. So the company that we got the tools from is called Zappy Sys. So they have this tool that would convert you know, relational database table into JSON document. And the really cool thing is that we could actually design the JSON document into whatever format we like, you know, including embedding data. And then from that, we can transfer the data or load the data directly from SSIS into MongoDB Atlas.
So that's so you installed an add-on, so to speak.
Correct.
And what's the name of that add-on? Can you repeat that?
Yeah, so the company name is, and it's also pretty much the name of the tool, is Zappy, Z-A-P-P-Y, and Sys, S-Y-S.
Excellent. Excellent. Because SSIS has been widely used in the industry, but usually we use SSIS with relational databases. That certainly has expanded the functionality of SSIS to work with non-relational databases. So thank you very much for the great work and presentation end to end.
Thank you.
And thank you for the question.
Thank you.
Thank you.
Let's welcome Team 6. Team 6 is Cosmos DB SQL API team.
Hello, Professor. Can you hear me?
Sylvester, you are on.
Hello, Professor. Can you hear me?
Yes.
Okay. Sylvester, go ahead. Hello, good afternoon, Professor and everyone present here. I, Sylvester Narona, and my partner Avish Naik are going to talk about our project, USA Car Accident Analysis. In this project, the resources and tools which we mainly used were Azure Cosmos DB, Azure Data Factory, and Power BI. So I'll begin by talking about our data set and what was our motive to work on this project and what we were trying to achieve. We got this data from Kaggle. We used a countrywide car accident data set which covered almost all the states of US. The accident data which was collected was from Feb 2016 to December 2020. This data set had nearly 4.2 million accident records. Our main motive to work on this project was to understand and study the different car accident hotspot locations, casualty analysis, and studying the impact of precipitations or other environmental stimuli on accident occurrence. basically to find out what are the factors that cause that accident to occur at that specific location and at that time. So this is an entity relationship diagram where you can see that the accident has other entities related to it, like road conditions, the location, and the climate, which affected the accident. Our motive was to completely work on a cloud environment. So because Azure is effective and robust in providing different processes and tools to handle the different processes like storing the data into block storage and then performing different manipulations and transformations on the data. So as you can see in the picture, our first task was to insert the unstructured data into block storage container. From there, we ingested that data to Azure Data Factory, where the transformation and manipulation of data was done. After manipulating and transforming the data in the data factory, we loaded that data set into Cosmos DB, where the documents were then connected to Power BI to visualize and analyze the different factors. So our first task was to upload the sample dataset in block storage container using storage about resource. As the data, as I mentioned earlier, the dataset was about 4.2 million, had 4.2 million records. Due to cost constraints, we had to sample the data to 150,000 records. After sampling and storing it into block storage container, our next task was to source the dataset from block storage to the data factory using the link services or connection string. This is where we corrected the data types of the column and selected only relevant columns which should be loaded into Cosmos DB, which will be effective to analyze the dataset and finding out about the accidents. So the hierarchy was something like this. We created a hierarchy using the derived columns schema modifier tool, and the hierarchy is based on our entity relationship diagram, where you can see the climate has the columns related to the climate, and similarly the accident details, road conditions, and location. This part will be talked about and explained by my partner, Manish.
Hello, Professor. So after creating the hierarchy, we decided to create a surrogate key. We created surrogate key to uniquely identify all the records using the surrogate key schema modifier tool available in the data factory. As we know, the Cosmos DB generates automatically generates key for every record. We didn't want it to use this automatically generated key, so we specifically decided to create a surrogate key for it. Go to the next page. After that, the surrogate key that we generated was in a integer form, so we needed to convert it to the string form, as the Azure Cosmos DB's ID key is in a string format. So we converted the string surrogate key that we created into a string. After converting and implementing all the data transformations, we loaded the data into the intended database. We mapped out the data and then implemented. This took, as the data resources on the data factory were low, it took quite a lot of time. It took almost 1 hour to implement the data transfer. Go to the next slide. After that, we run and debug the process of the pipeline and transfer the data to the Azure Cosmos DB database. This was the output in the Cosmos DB database. We can see we laid out the data quite in a separate indentations to get a more clear view of the data. Next slide. After that, we use Power BI as our data visualization and analysis tool. As a Power BI gives us a real-time dashboard. It seamlessly integrated with the Cosmos DB interface. This was one of the visualization we created. This gives us the information about the accident counts in the region, depending upon what were the weather conditions. As we can see, the most of the accidents happen when the weather conditions were fair. Though this this visualization gives a data. This visualization gives a brief understanding of how the weather conditions affect the accident count. Next, this we are also created a dashboard which gave us the information about accident hotspots based on locations, weather conditions, and accident severity. So this was an interactive dashboard that we created. We can it gives us a lot of information about the how the accident happened, what were the weather conditions during the accident, what were the severity and the count of the accident in a certain severity region, and also by the states or in which states what accident occurred. Can you go to the next slide? Yeah. So after that, we also created an accident analysis based on the road situation and road conditions. If this dashboard gives us accident details based on if there was a accident on a exit or a stop sign. Yeah, we can select specific conditions for an accident, and it gives us information of the whether the accident took place in which region and what was the accident details in the description. Also, it gives us information about how if the road was affected during this, how much distance of road was affected during this accident. Can you go to the next slide? Yes, what we missed, the data set was about 4.2 million, as you mentioned before. We could only use 150K of the records, hence the visualization were not that accurate, and we also couldn't implement a prediction model as the data was quite low. That's it. Next. That's it. Thank you. If you have any questions, we are ready to answer.
Yeah, so I have a few questions here, and just a disclaimer, I was really having a hard time seeing what was on the slide because I'm using a pretty small screen. So some of my question might, you may have shown it in the snapshot, but I just couldn't see it really well.
I can explain those.
Yeah, so I guess first question is why converting surrogate key to string before putting that in Cosmos DB?
Yeah, it was better to understand it for our purposes because it would streamline the whole key, so we could like serially do the key rather than it's just randomly generates.
So sorry, I'm not sure if I'm getting it. So I guess my question is that, like, usually when we think about any kind of key, like primary key, surrogate key, candidate key, I would be thinking that like integer might works better than having the data type as string. So that was my question, pretty much.
No,
So why convert it?
So the Cosmos DB ID key is in a string format, so it doesn't take integer. So even if we give it an integer format, it will again automatically generate an ID, which is in a string format.
Oh, okay. So it's like a long
Yeah, it's a limitation of the
ID,
Cosmos
right?
DB.
Got
It is
it.
a limitation of Cosmos DB that it converts it to the string. It requires it to convert it to a string.
Okay, gotcha. So second question is, how do you connect Cosmos DB to Power BI? Is the Power BI integrated in Cosmos DB?
Yes, it's a live. It seamlessly connects to the. You just have to share the key with the Power BI, the key which you used on the Azure Cosmos DB platform to the Power BI, and it connects it to the Cosmos DB in a real time.
Okay, that's cool. So the last question for me is, based on your analysis, what U.S. state has the highest concentration of accident?
So most of the accidents were in the state of California, and most accidents happen in the weather conditions which are fair. Though this data set was like quite small, the actual data set is quite big. So I don't think the actual analysis that we gave is quite relevant to the actual data set.
Okay.
because it's the 4.2 million data set and we just use 150K of it.
Mm-hmm.
So I don't know if that's the actual data set, but what we analyze from that, we could tell that the California state has the highest rate of accident.
Okay.
And those were most of them were during fair conditions, weather condition.
And how is Massachusetts? The reason I'm asking is I'm gonna be there in 2 weeks driving. Just want to make sure if it's good or not. We're in Seattle, so.
Mass was quite low on it. I think it was 8th or 9th.
Okay, sounds good. All right, I'll let my other teammates ask questions. So thank you.
Okay, thank you.
Hi, I have one question. You mentioned because the Azure has the limitation for the size.
Yeah.
How did you select? How did you cut? Like, did you do
So,
the randomize or
yeah, no, we use Python for to sample the data. So Pandas has a function called sample. So we use Python to randomly sample about 50K of the 4.2 million data, and then we exported that to CSV, and then we used that file.
Got it. So you use the Python to pick.
Yeah, we
Okay.
use Python to randomly sample 150K data from the 4.2 million data set.
So you didn't have to pay anything doing this project, right?
Some charges in the data factory and Azure resources, like $50 around.
Yeah, I was asking that because I got charged for doing the homework in Cosmos DB. So
Yeah, it sure charges you.
Mhm.
We created a new account where we got $200 credit.
Yeah, we had to create another account for it.
Right, because it's only a month or something.
Yeah,
Okay,
yeah.
cool. Thank you.
Yeah, thank you. Any other questions?
Very good presentation and work. Well, your money was well spent. I do have a question.
Yeah, sure, Professor.
So you use the data factory
Yes,
for
Professor.
ETL and for creating the data pipeline.
Yeah.
Could you tell us what specific tools or programs you used? The tools or programs which were included in the data factory.
So data workflow, so when you enter the data factory interface, you can create a workflow or a data flow. So the workflow is just it runs multiple data flows. And once you create a data flow, you can create like in this presentation it's showing, we can create a specific data flow to transfer the data or whatever here, and then we can run it through the workflow that we have created in the data factory. The workflow itself converts the CSV format to the JSON format, so we don't have to do the conversion separately. We just have to select the outgoing database and it automatically detects that it's a JSON format database. So it automatically converts it to the JSON format. Does that answer your question?
Yeah, sure. Excellent. Thank you for sharing the info.
Okay, thank you.
Any other question or comment for Team 6 for our Cosmos DB SQL API team? Okay, so again, thank you for the great work and the presentation from Team 6, and the Q&A session was very interesting, very informative as well. Thank you all for your contribution to the project presentation. Let's welcome Team 7.
Hello, Professor. Can you see my screen?
Yeah, you are on. Go ahead, please.
Yes, so good afternoon, everyone. And our project is on data modeling of the Yelp reviews using MongoDB. So Yelp is a American company which has different businesses that have been listed on their website, and people can go there and review different types of businesses. While some businesses allow people to make reservations, and so it has a lot of data, and the main challenge for them was to build a data infrastructure that will handle this amount of data, because the data is almost being generated after every second or after every minute. So our objective for this project was to design a system which will use this data to provide insightful analytics for users as well as the existing business owners, because as I explained, like there is like exabytes of data which is being generated every single day, and we wanted to choose a platform where we can utilize this data and create that infrastructure. We decided to go ahead with MongoDB because it has good compatibility with the developers, and also the fact that it scales horizontally and can handle huge traffics of data. Next slide. So the architecture diagram was that we had different data sources like the JSON and CSV files. And one more which was missing in the slide was that the website has a free API called Yelp Fusion API, which generates the data, or we can get the live data out of that API. And the first approach was to work with the Azure Data Factory to have the source as the live REST API. But the limitation with the free API was that there were very few API calls available for us monthly, and each API call was only giving us 50 reviews. So the amount of data that we were getting was very less. So we utilized Kaggle, which had already huge amounts of data, which was around 21 gigabytes. And we decided to have that as a starting point for our project. Next slide. Yes, so starting with the input data files, we utilized Kaggle kernel and its notebook for the pre-processing part, because we did not have that amount of power on our local PC. So that's the reason we used Kaggle's notebook to sample 1 lakh reviews from the different restaurants, and we exported the files as CSV for using them with Colab. And this was the part of the ETL process, because we decided to go with an ETL script in Python because it gives us more control over the kind of data extraction that we can perform. And since we wanted to load the data into Cosmos DB, MongoDB API for Cosmos DB, so we used PyMongo for it, and it gave a good compatibility with our notebook and the Cosmos DB. Next slide. And the script was in such a way that all of the things which we do on the different ETL softwares, we could have a better control by scripting it out and loading the different tables into it. Snehal will continue the further.
Hello everyone. So here is our ER diagram. So basically Yelp review analysis is based on the reviews which are given by the users for different kind of businesses. So here are a few essential entities mentioned here. Those are business, review, users, check-in, tip, etc. Next slide. So here we created few tables based on our ER diagrams and populated the data through MongoDB. So first is the business table. So it is just a local body on the Yelp, like restaurants, stores, departments, other services, cafes, etc. And next is the user tables. So here the user is a person who is registered on the Yelp and who is responsible for giving various kinds of reviews based on his experience after his visit to this different kind of businesses. And there are also some users who are just here to look at the reviews and choose the businesses based on those reviews. Next slide. And the next table is the check-in table. So it has just the basic check-in details about the businesses in the form of business ID, date, from, and to. So this gives the more insight about like the good time to visit that particular businesses, how crowded it is at that particular time, etc. And the tip table, it has the details of the tips, which are like a way to pass along some key informations for the businesses. It also gives some analysis about how popular the restaurant is. Next table, next slide. So the main table here is the review table because it based on the review analysis. So review has all the review ID, user ID, business ID. So it has all the review informations which are provided by the users based on their overall experiences. And it also helps us to analyze how the business is doing the progress or how popular it is. And it also helps us to compare two different businesses at a particular location or a different locations and etc. The rest will be covered by Sumit.
So after loading the data into MongoDB, we use Mongo charts for visualization. So for Mongo charts, the data set was very huge. So we have to filter it on the basis of cities. We selected 4 cities, that is Atlanta, Austin, Beaverton, and Boston, in which total business count was around 3336. So the first chart is the category versus the rating of business. So which indicates the average rating between 0 to 5 for all the business based on the category list, which can help like the uh, low performing category to help them. The next chart is the how the all combined businesses averagely performing in the cities. As we can see, Boston is like performing very badly in terms of average rating. So the businesses are not like they are not providing proper service to the customers. Next is based on the geographical location. So we can see like which cities or which state are performing better in terms of average ratings. As we can see that Beaverton has like overall pretty good rating compared to Boston. Uh, so the next one is the most useful business reviews. It shows it is created using the review table. It contains various attributes which help us to analyze the which is the most useful review given by the users as well as marked helpful by the users. So for every rating there are like different whether it is helpful, not helpful, and based on that we did sentiment analysis. It has like various tables, complimented, funny, and everything. So this contains which ratings are the most useful one. Though the next one is the sentiment score for the stores. Sentiment analysis, like it is a way of quantifying the feeling or tone of the written text or the written review by the customer. It is one of the most useful technique for gauging all the overall attitude towards a brand, product, or feature. In this case, businesses. So for us, we like this graph can be used to check in like which restaurant or which business in the city is performing badly, and then they can improve. Here we can see that the Man in Motion and the Champion Beauty Supply Store and the Shade Window Tinting, these three are like getting almost zero reviews, so they are like not very popular with the customers. So next is this is the business rating over the years, like how the overall business in the city like Atlanta, how they are performing over all the years. So for Atlanta, it started with like 4.4, where they had like very good rating, and then the ratings keep on decreasing after some time. And in the Beaverton, it was like 2 as an average rating, and they improved pretty nicely. So that's all for our presentation. We are open for questions. Also for live data refresh, like we have the ETL script ready in Python. So uh, we were trying to we can use the instead of giving the JSON path, we can just give the S3 bucket path, and then we can schedule it using AWS Lambda for a weekly, daily, monthly, or any amount of time what we can do for live data refresh.
Can I ask a question?
Yeah.
So while working on the ETL process, like what was the most difficult task and how did you guys handle it?
Sorry, I was not able to hear you.
Hello.
Yeah.
So my question was like, while working on the ETL process on the Python code,
Yeah.
how did you guys manage to handle, like, what were the problems you guys were facing while doing it on Python?
So starting with the first problem, like our data set was very huge. The reviews we have to sample it like it was some in GB. So we sampled like 100,000 rows in review, but we kept all the businesses, all the users, all the check-in and all that is because all those four tables were necessary. And like first thing was uh, look up using on those businesses because the 100,000 reviews, like some of them were like giving null values, so like cleaning the data, after that dropping the duplicate values, and like everything, creating it on a single script so that it can be used in Lambda, like the perfect scripts, so it can be used for scheduling. That was like a difficult part. So this is the like last script we were able to do, and like if you just run the script, it will do all the ETL process in like one go. It's just you have to put your Cosmos, the Mongo API, which is from Cosmos, so the data directly goes into there. And this is all the data cleaning and data profiling.
Okay, yeah, that sounds good. Thank you for answering.
Thank you. Anything? Professor?
Sure, yeah. Any other question or comment for Team 7? Excellent work and presentation from Team 7. I really like your data analysis and thank you for the questions.
Thank you, Professor.
Sure. Last but not the least, let's welcome Team 8.
Hello everyone. We are Team 8 and I am Priyanka and my teammates are Thin and Yin Song. And today we are going to present our project on US airline on-time statistic. So as we all know that COVID-19 has grounded international and domestic travel and the government of every country is trying to manage and contain the spread. So we got to know that according to IATA, the global passenger traffic as measured in revenue passenger kilometer declined by 65.9% as compared to 2019, which is a huge number. And hence, international travel and domestic travel came to a near complete standstill in 2020. The aviation industry has suffered a lot. So, understanding what happened last year will help us to understand the trends we see now for our US airlines. Here, we will be mainly focusing on reporting our four major airlines of United States. That is American Airlines, Southwest, Delta, and United Airlines for a month of December 2020. Our final statistics with the previous year data will help airline companies and their customers to make better business decisions and travel plans. It will also help in choosing a specific airline for their travel. So for our project, our main data source comes from Bureau of Transportation Statistics. And to work on our data, we used MongoDB platform as it is a NoSQL database and it has many advantages like the aggregation framework, file storage, indexing, sharding, and like many more. We also use MongoDB Compass for collaborating and importing data. Uh, and the GUI help to explore, analyze, and interact with our stored data. Currently, we are focusing mainly on showing the statistics for our route variety, time variety, like passenger revenues for a particular month, delays of the airlines in terms of various reasons, cancellation rates and reasons, and finally the taxi in and the taxi out time. This is our ERD which comprises of 6 tables, with the flight table as the main table, and the table in dark green that are ticket price, the flight route, the delay records, are the process data table, where the process data table is the data that we process from our raw data. We perform some cleaning and transformation to convert the raw data into a format that can be analyzed and visualized first. And the table in the light green that are airport table, airline table, and the cancellation record are the dimension table, which consist of non-repeating values. And the further will be continued by Thin.
Okay, so like the story is all about like we are migrating data from a star schema to a snowflake schema. So like what we know about star schema is that they have a lot of data redundancy. So when we first like mine the data, when you first mine the data, so the zip file is only symbolized 16 megabyte data. But then when we try to unzip the file, it got a lot bigger to like 56 megabyte data. And then like when we try to upload like the file to MongoDB, and you can see like the storage, it exploded to like 288 megabyte data. So there's a few reasons for that, because like there are a lot with like multiple kind of like airline. So we have to filter and retain the 4 major airline for all analysis. And because like we are migrating from the star schema, so there were a lot of redundant columns that have to like trim out. So eventually the final size got reduced to 68 megabyte data. And then we are moving like all like our process data to like the table where it's supposed to belong. And then the raw data will be deleted so that like new data can come in and continue the cycle again. And then finally, we will have like some visualization which Yin will present.
Okay, so we analyzed the performance of 4 major US airlines: Southwest, Delta, United, and American. We want to figure out whether their travel policies has affected their total revenue and total flight performance in last December. We analyzed the flights and delays in December 2020, especially because they have strongly bonded with travel delays and strongly seasonal reasons. The airline delay has, could you go to the last slide, please? Thank you. They have experienced the travel disruptions strongly last years. Many states are restricting travel to slow down the spread of new coronavirus. And this, meanwhile, has reduced the total revenue of the travel in last December, comparing to the revenue in 2019. There are $18 million deductions. Thank you. And however, when we compare the total revenue of 4 different airline companies, we realized that the one who has not eliminated travel waivers has a higher revenue than the rest of 3 companies. And this might potentially means it has a better flight decision to let users to waive their flights. Next, please. And this result confirms our assumption, as the Southwest Airlines enable users to waive their flights without penalties even if not eligible before the pandemic. This may potentially lead users to use their flights and service compared to the other 3 companies. In the future, we may compare more data of the past years to figure out if the travel waivers is the major reason to increase their revenue. And this is a really useful tools for future analysis. Thank you for listening. Do you have any questions?
Thank you for the presentation. I have only one question, like how did you handle deletion of the existing records and inserting the new records? Was it through an ETL technology stack or through a code?
So technically, when we import the data, it's like on a CSV file, and then after that, it's just like it's just simple like scripting on, and I use a tool called like NoSQL Manager for MongoDB. So like I would recommend everybody use it because like it isn't like it have like the regular SQL interface, and you can just like delete everything easily.
Thank you.
Any other question or comment for Team 8? Excellent work and the presentation from Team 8. Great presentation and explanation on your ETL and data pipelining operation. Thank you, Team 8, and thank you for the question. I was very much impressed with your accomplishments. We had great work and a great presentation from all of the teams. Kudos to everyone. This is the end of our presentation. So I'm not able to stop the recording. Can someone else stop the recording? I was able to see that. But now I'm not seeing that. So let's see where that is.
So
Okay.
it should be, yeah.
Yeah.
So